Hello students, today we will start curl of a vector. So previously we have already done the divergence of a vector. Divergence actually shows the extension, there is expansion or contraction of a vector field. Now curl means it defines the rotation of a vector field. That is, suppose just look at this picture. This is the geometrical interpretation of a vector field, of a curl of a vector. So now a particle, so this object or this particle, it is rotating around the curl vector. That is, curl means it is a cross product. So we already know that a cross product means it has some direction, because cross product is a vector product, and vector product means it the result is a vector, and a vector always has some direction. So in case of the cross product, we know that the direction of the cross product is actually either the perpendicular direction, that is either upper perpendicular or the lower perpendicular. So in the similar manner, since the curl is also a cross product, so it has also some direction. And now suppose the geometrical interpretation is like this particle is actually, if this particle is rotating around this vector, suppose this is a rotation axis and this particle is rotating around this axis, and now the direction of this rotation, look at the direction. Okay, if the direction of this rotation is from right side to left side, then we know that the vector direction is actually the upside, that is normal to the vector and normally upward. So this is the actually direction of the curl vector. So curl defines is actually rotation, and the direction of the rotation is actually the perpendicular direction. Now let us come to the problem. Now this is a mathematical notation of what is curl. So we have considered a vector field, a differentiable vector field Vxyz. Now the curl of a vector is defined. We know that this is a cross product curl. So grad cross V. Okay, so other than the divergence, we know that grad dot V defines the divergence, and grad cross V, it defines a curl of a vector field. Or simply we can write this curl V or rot V or rotation of V. And we know what is this is the gradient sign. So grad means I del del x plus j del del y and k del del z, and cross product. And let us suppose this vector V, it is a vector field, so obviously we can consider this vector field V as f1i plus f2j plus f3k. Now simply the cross product is here. Now what we do, just multiply this as a cross product. We know the definition of the cross product is, this is a determinant, and ijk, the since these two are cross products, so ijk will be the first row of this determinant. The second row will be the component of the first vector, that is del del x, del del y and del del z. The third row is the component of the second vector, it is f1, f2 and f3. Now simply we are expanding this determinant, and after expansion we are getting this one. Just simply with respect to I, that is this into this minus j into this and plus k into this. So it is simply we are expanding this determinant and we are getting this formula. So simply we see, in case of divergence, divergence is grad dot v. So it was a scalar quantity, because dot product is a scalar vector, and sorry, dot product is a scalar, the outcome is a scalar. So there is no ijk in case of dot product. Now that is divergence. But in case of cross product, we know curl is a cross product and the result will be a vector. So let's see, this vector I, j and k is involved in the outcome, so it becomes a vector. So we just need to remember this formula, or simply we can also remember this determinant. Okay, so it is easy to remember this determinant, okay, other than this formula. Now let us come to this example. The first example is a vector field is given A. This is the vector field. Now find grad cross A or curl of A at this point 1 minus 1 1. So how can we find it? Simply we are just perform this cross product. Okay, you can also skip this step if you if you can remember this determinant. You can skip this step, that is this cross this. We know the delta, that is nabla, it is a gradient or grad operator. So we know the grad operator is I del del x, j del del y, k del del z, and the a vector is already a given vector, this one. So we can skip this step and directly we can write this determinant if you want. So now expand this determinant. So after expanding, apply this formula. Okay, because after expanding we are the result, outcome result will be this formula. So simply we can just put it into this formula, or just simply we can expand this determinant, and after expanding this determinant we are getting this one. So del del y of 2y z to the power 4, it is with respect to y derivative. So obviously only y is a variable and z is a constant, because this partial derivative with respect to y. So simply now this is also del del z of this. So this partial derivative with respect to z. So x and y is a constant here. So simply we are doing like that, and we are getting this result after expansion. Now we are required to find out the curl at which point? At 1 minus 1 1, that is x equal to 1, y equal to minus 1, and z equal to 1. Now simply put the values here at x equal to 1, y equal to minus 1, and z equal to 1, and we are getting this one. Look at this, is a point. Obviously x, y, and z is replaced by some point, so obviously we are getting a vector point like this. Now come to the second example. This is we need to find the curl of curl A. Okay, so double curl, there is a vector field is given, and we need to find the curl A first, and then again we need to take another curl of this curl. So this is double curl. So simply we write the formula. We know curl A equal to grad cross A. Now grad cross A, again another curl is there, so grad cross A. Okay, so now we are solving this problem one by step by step. First curl, just fix the first curl. Now expand this one, grad cross A. First expand this one and start with the right side. Okay, so we expand this one, we are getting this formula. We know that these are determinant, and determinant is like this, and after expansion of the determinant we are getting this. Now again grad cross this one. So look at this, after expanding the determinant, this is another vector field. Now grad cross another vector field, obviously we are getting another uh, curl formula, that is ijk del del x del del y del del z. Look, this first two ray is always fixed, ijk del del x del del y and del del z. Only the third row changes, and that is the this vector field, that is the component of I, component of j if exists, and component of k. So component of I is this one, component of j, there is no component of j, so put here 0, and the third component of k is this. Okay, now expand this determinant and we are getting this formula. So this is the answer. Now come to the third example. Grad dot a cross r, if grad dot a, so we need to evaluate this term, grad dot a cross r, if grad cross a is equal to a zero vector. Okay, one thing is to be remembered, sometimes we write 0 and sometimes we write 0 vector. Okay, so remember, if this is a cross product, we know the result of a cross product is always a vector. Okay, whether it is 0 or something else, if we write 0 also, then also we have to write down the vector sign here. Okay, in case of 0, because there is a cross product. If there is a dot product, we do not write this, or we do not mention this vector sign. This is simply 0 without any vector sign if it is a dot. But if it is a cross and the result is 0, we obviously write this vector sign here because this is a vector product. Now we are evaluating this. Now A. So nothing is given here. So obviously, what is A? A is a vector field. Okay, A is a vector field, so any vector field can be written like this: A1i, A2j plus A3k. Okay, where A1, A2 and A3 are some functions of x, y and z. And R is any arbitrary vector. We know any arbitrary vector point can be written like this: xi plus yj plus zk. Okay, any arbitrary vector point can be written like this, and any arbitrary vector function can be written like this: a1, a2, a3, that is a1i, a2j and a3, a3k, where a1, a2, a3 are the functions of x, y and z. Now we are evaluating this a cross r equal to, just this is a cross product, just simply write down this determinant ijk, this one and this one, and we are evaluating this, expanding the determinant, we are getting this one. Okay, now come to this result. We have this one, a cross r, and the result is this. Now we need to evaluate grad dot a cross r. We already have, this is the a cross r. Now we are putting grad dot. What is the value of grad? I del del x, j del del y, k del del z. Dot product of a cross r. Okay, so now put these values. A cross r value is this, putting the value of a cross r, and we are getting this. Now what is this? This is a dot product. Simply it is a dot product. Dot product means just I dot j is 0, I dot k is 0. Okay, so only we are having del x of I dot I equal to 1. So del x of a2z minus a3y. So del x of this, because I dot j is 0, so this term will be 0. I dot k is 0, this term also will be 0. Simply j del y of this, j dot I is also 0, so it is 0. J dot j is 1, so we write del y of this. Just simply dot product, what dot product has. So we are getting, similarly for k we are getting this one. So after this dot product we are getting this result. Okay, now look at this. Now simply we are multiplying, that is del x of, now look at this, z. Okay, z is came outside, and del x of a2, we know what is a2. A2 is a function of xyz. We don't know what is the function, but it is a function of xyz, so we simply write del a2 del x. We don't know what is the value, but simply we write here. And what is z? Z is also a variable, but z is treated here as a constant because the derivative is with respect to x, so z comes outside, so we write here del a2 del x. Similarly here del a3 del x, and y comes outside because taking derivative with respect to x. Similarly all these vectors, all these, just simply multiply this one, or just operate a3, operate del y on a3 and a1, and we are getting this result. Okay, now look at this. There are 2x, there are 2y, and there are 2z. Okay, so from this 2x, just let us take x common, and we are getting this result. Let us take y common, we are getting this result. Let's take z common, and we are getting this result. Okay, this is nothing but, if I write here, look at this, xi plus yj plus zk, and this one. Okay, so just simply we can write this step as this one. Why? Because multiply this one, x into this one, I dot I equal to 1, so x into this one, look at this, x into this one we are getting here. Okay, now xi into this one, we know I dot j equal to 0, so xi into the second term it will be 0, xi into third term it is also 0, because I dot k is 0. So x into this one, look at this, it is 0, so only we are getting x into this. Similarly y into this j dot I is 0, we are not getting this one. Only y j dot j is 1. So y into this one, look at this, y into this one. So we can write this step, that is this second step, like this. Okay, now why we should write it like this? Because we know xi plus yj plus zk is equal to r, and this term can be written as del cross a. Just recall the value of del cross a. What is the value of del cross a? Look at this, del cross v or del cross a, whatever the value of this curl, the curl value is this one, I del f3 del y minus del f. So this one is nothing but this. So we can write this one as del cross a. So r dot del cross a. So why we are writing like this? Because a value is given del cross a value is given as 0. Look at this, del cross a value is given as 0. Okay, and we need to evaluate this one. So del cross a value is 0, and we are getting the end result as del cross a as one term, and r is with a dot product of this, and del cross a is 0, so we are putting as 0. Okay, so r dot 0 vector, what is this? It will be a 0. Now look at this, r dot a 0 vector, we do not put a 0 vector here because there is a dot product. We only simply write 0, and hence this is the answer. Okay, thank you for watching my video.